a rope is being wound around a drum with a radius of 0.327 meters. So I have my R. How much rope would be wound around the drum? So the rope is going around the outside. So what variable do we use for distance around the outside? S. So we're trying to find our S. If it's rotated through an angle of 132.6 degrees, so your angle is theta. But what do I have to do first? So how do we change to radians? See, you guys do remember something.
It's crazy.
It is. All right, so if I do that, remember when you type it in, you do 132.6 divided by 180, and then we stick the pi back on. If you go math number 1, it would write it as a fraction. So we get 221 pi out of 300. So now we can use our formula, S equals R theta. You'll notice I'm kind of in the habit, I like to write out every variable that I have, and I like to write my formula. It seems kind of silly right now because we have one formula, but in section 3.4, we're going to get a lot of other formulas, so this just kind of helps me organize and preparing us for when we have more formulas to use. So S is 0.327 times 221 pi over 300. And I've told you there are a lot of ways you can write your answer. You know, if you just do a decimal, you get 0.24089 pi. This one doesn't really turn into a fraction. You can change it if you want to go ahead and multiply out the pi. You could say that's 0.7568. Either one of those is okay. So whether you multiply out the pi or not, I don't care. You just have to make sure you are labeling accordingly. S is arc length, it's a distance, so its unit will match your radius, so that would just be meters. So either of those is fine. Is that okay? So get another one. Two gears are adjusted so that the smaller gear drives the larger one. Do you know what that means? It means they're touching each other and you're spinning the small one, which in turn makes the bigger one turn because they're touching. If the radii of the gears are 3.6 inches and 5.4 inches, and the smaller gear rotates through 150 degrees, through how many degrees will the larger gear rotate? So we have more information here because I have two different gears. So I like to organize. I've got my small and I have my large. The small one, the radius is 3.6. The large one, the radius is 5.4. I told you that in the small one, the angle is 150 degrees. What is that in radians? Remember, this is a reference angle of 30, and if it's at 30, it's always pi over 6. In the second quadrant, the numerator was one more. If we think about that circle patterns that we've seen. And I'm trying to find the angle for the large one. So we really have very little information so far. Let me ask a question. So when I say the smaller gear drives the large one, so as this one spins, it causes that one to spin. So what's the same in both of these? The amount that it's spun, right? So those are touching, so it's the same distance for both of them. Can we find S in the small gear? Yeah, if we did S equals R theta, (3.6 times 5 pi over 6), what do we get? But that's the same for both of them. So, in the large one, if we do S equals R theta, the S is 3 pi, the R is 5.4. So if I want to solve for theta, my theta is 5 pi over 9. Am I done here? What did the question ask?
How many degrees?
How many degrees? I've given that in radians. So if I want to convert that to degrees, what do we multiply by?
180 times 12.
So 5 over 9 times 180 is 100 degrees. All right. Questions there? So it's really just a matter of plugging things into our formula and solving for the unknowns. There is one other formula we're going to use today. And then like I've told you, we'll be getting a formula sheet on the tests and quizzes from now on. So you don't have to memorize these, you just have to know how to use them. This first slide, I was just going to kind of show you where the formula came from. So I'm not going to ever make you recreate it, but I just kind of want to show you that it's not just totally made up. We know how to find area of an entire circle, right? Area of a circle is pi r squared. You've used that before. When I want area of a sector, I'm talking about just area of a portion of a circle. So we can find that by setting up a proportion. We know the area of the whole thing is pi r squared. So if I want area of just a certain portion, I need that angle. And we know that in that angle, if you were talking about the whole circle, what would your angle be if you went all the way around the circle? 360 degrees, which is 2 pi if we're in radians. So area of a whole circle is pi r squared, the angle in a whole circle is 2 pi. What happens to those pi's? So if I wanted to solve for area, you can multiply over your angle. So we get r squared theta over 2. Another way we can write that is 1/2 r squared theta. So that is the next slide. I did just give you the formula. Again, it'll be on the formula sheet. Just like everything else, for this to work, theta has to be in radian form. So that's our formula for area of a sector, so a portion of a circle. So if I want the area of this sector, I have my radius, that's r. Central angle, what variable is that? What do I need to do to that? change to radians, so multiply by pi over 180. So we get 3 pi over 5. Everybody with me so far? So then the formula, area is 1/2 r squared theta. So we just multiply all this out. Again, I don't care if you leave the pi in it or if you multiply out the pi. Area is always square units, so that would be square feet. So far, so good? I think I am going to, I want you to take a look at that last example and see if you can set it up on your own. So, what's the radius?
30.
What's your angle?
90.
90 degrees, which is equal to pi over 2 radians. We want the area. So 1/2 times 30 squared times pi over 2. So you get 225 pi, or if you multiplied out the pi, 706.85. If I said 3 significant digits, what would you have to round that to?
77.
And what would my units be? All right. Are you okay with that? So I want to give you guys some time to work so we can ask questions. This was a pretty short section.